Welcome to Techno Decode. Our first decode is Prophets of AI, and here we'll consider people who have shaped the way we see and understand artificial intelligence. And for this series, we'll consider primarily the work of Michel Serres. The French philosopher Michel Serres is likely one of the most significant thinkers of technology and culture that you've never heard of. Serres began writing and theorizing on the information age and the rise of network culture back in the late 1950s and early 1960s in France. He was substantially influenced during his graduate years by early scientific work in chaos theory and information theory. For Serres, these developments marked paradigm shifts that were a radical departure from the fundamental principles underlying classical mechanics, physics, and scientific determinism. These shifts might be described as progressions from simplicity to multiplicity or complexity. Serres' early academic work was concerned with updating Leibniz's metaphysical monadology, also called the communication of substances, with a more contemporary theory of the communication network. To this effect, Serres wrote a series of books named after and thematized upon the Greek god Hermes. And these books were devoted to developing his self-styled network theory. Hermes, the god of communication, commerce, travel, invention, is symbolic of the network. He is god of the crossroads who guides travelers and voyagers. But he's also a formal lattice structure that makes ideas like neural networks or communication networks mathematically conceivable. But also ideas like a web, a weave, a sponge, an ecological system, a social network, or a communication network. These are all thinkable because of the mathematical formal ideal which allows for them to take form in the material realm. These can only be materialized and actualized because they are formally conceivable mathematically. Hermes marks a shift from simple pathways and lines to broader, more complex weaves, networks, and road systems. Communication and commerce are higher order, complex social behaviors that are emergent from local interactions between simpler elements. This marks an example of order emerging out of chaos or an emergent whole that is more than just the sum of its parts. Serres' early work is also a precursor to later developments in complexity science. Cultural theorist Mark C. Taylor has written extensively on complex adaptive systems as a theoretical tool for understanding culture. He borrowed this term from complexity scientist John Holland, who said that adaptation builds from simple orders towards increased complexity through recursive feedback loops. A hidden order is produced by the emergence of complex large-scale behaviors from the aggregate interactions of less complex parts, and this is how simplicity blossoms into complexity. When a simple order morphs into a more complex order, or when order emerges out of chaos, the underlying structure is preserved such that a simple order is structurally isomorphic with the more complex order. Isomorphic here means same structure. This makes it easy to identify and compare simple and complex orders. Such comparisons translate the same message or structure on both simple and complex scales. So, Serres is significant because he, number one, develops a philosophical network theory based on the work of Leibniz, but updated with modern information theory. But he also, number two, develops a methodology of structural analysis called logoanalysis that compares simple and complex orders via events. In Serres' methodology, logoanalysis utilizes his philosophical network theory to translate events, both historical and literary, on simple and complex scales, and demonstrating a scalar shift from simplicity to complexity. Serres' use of structuralism in logoanalysis is primarily driven towards promoting a non-foundationalist or pluralistic perspective. Christopher Watkins calls Serres' approach aspectualism. Essentially, the approach is to view an event from multiple perspectives, privileging no perspective in particular, and this is effective from a shift from a simple point of view to a more complex point of view. One of the most difficult and controversial features of Serres' work is his structuralist method. His method is influenced primarily by a group of mathematicians from the 1940s, 50s, and 60s who went under the pseudonym Nicholas Bourbaki. The group endeavored to construct an architecture of mathematics in its entirety, founded upon its simplest elements and built towards its most complex elements. The Ravaki group influenced Serres' use of the term structuralism and the analytical tool, which was rooted in formal mathematics and mathematical history. Serres also witnessed a paradigm shift in the field of epistemology. The traditional perspectival epistemological model highlights the priority of certainty in supporting determinism and aligned with scientific determinism. This is the basis for exact knowledge, precision, and focus. And as a result, certainty is the basis of all foundational knowledge. It's a weapon of choice based on foundationalism because through certainty, the foundation and origin is unquestioned, and so centralization relies on certainty. But as we move from classical mechanics and classical mathematics to modern mechanics and modern mathematics, the value of certainty under simple calculations is replaced by the predictive value of approximations, which can account for greater numbers and numerical complexities and variations. As complexity grows, decentralization becomes more adequate as an overlying model, as it relies on approximations and is more flexible and adaptable. The shift from simplicity to complexity also registers as a shift from traditional philosophical logic to modal logic. Traditional philosophical logic is practical logic under deterministic principles, such as the law of non-contradiction, which says that an object cannot be both A and not A. The law of non-contradiction is the engine of dialectical theory, which argues according to opposites. Dialectical theory is the basis for Platonic dialogue, where truth and knowledge are worked out between two speakers representing two opposing points of view. So for Plato, dialectics is the highest form of philosophical reasoning, and this idea would later be developed by Hegel and Marx to become a predominant social theory. Modal logic, by contrast, utilizes models and is concerned with questions of possibility, probability, and necessity. Our modern sciences are informed by approximations and possible worlds, and they frequently operate according to modal logic. Modal logic featured prominently in the metaphysics of Gottfried Leibniz, who heavily influenced Serres' early work. Leibniz was an enigmatic polymath who lived during the Baroque period. He famously invented calculus independently alongside Newton, with Newton inventing calculus first in the mid-1660s, but publishing after Leibniz, who developed his calculus independently in the mid-1670s, but then publishing first in 1684. Leibniz is considered by many to be the godfather of the information and AI age, at least theoretically, because he first conceived of a universal symbolic code called a characteristics universalis, or universal characteristic. This coding system for Leibniz would be capable of expressing all concepts associated with mathematics, science, and metaphysics. He also proposed for the characteristics universalis, or the code, to work in tandem with a calculus ratiocinator, or a reasoning calculus, which would be a computational machine to perform calculations that solve complex philosophical disputes and problems. Additionally, Leibniz developed binary arithmetic based on the numbers 1 and 0, and he also divinized the binary system. For Leibniz, 0 and 1 are not just numerical figures, but they are fundamental representations of God's creation from nothing, or creation ex nihilo, using 0 for nothing and 1 for God. Later, of course, Leibniz's visions of calculating machines operating under a universal code would be realized as the coupling of binary code and AI with network computers, which now aim to resolve complex social problems, to reduce waste, and produce material abundance. Serres' first published philosophical text was a gargantuan volume on Leibniz called The System de Leibniz. In short, Serres' book on Leibniz stresses the ways in which the Leibnizian philosophy is decentralized rather than centralized. Various structures in the Leibnizian system operate as elementary tools, with no one structure in particular dominating as a central theme, or underlying principle or fixed point for stabilizing the overall system. Rather, the Leibnizian system confederates and holds together according to decentralized web-like associations. Serres' decentralized pluralist approach is in contrast to what he criticizes as umbilical thinking, which is basically the idea of centralization. He dislikes the idea of a fixed point or centralized focus or univocal point of view that operates to stabilize the entire system of knowledge or ideas. Serres' theory aligns perfectly with the tradition of non-foundationalist thinkers who reject the idea that knowledge can be founded on a simple Cartesian subject-object division with a self-evident basis for cogito, the thinking-knowing subject. I think, therefore I am. On the foundationalist Cartesian model, the self-awareness of the thinking subject produces maximal certainty against minimal uncertainty or doubt, and this is the best foundation for knowledge. This is precisely the idea that Serres rejects. Serres' philosophical network theory is thoroughly infused by the information theory developed by American mathematician Claude Shannon and expanded by French physicist Léon Brimois. The brilliance of Shannon's work cannot be understated. He invented the mathematical language for what later became digitization, which shapes every facet of our global culture today. He did this by figuring out a formal way to reduce information to a fundamental binary unit called the bit, laying the groundwork for the invention of the computer and the digital age. The genius of Shannon's work actually comes from his adoption of Leibniz's work on binary arithmetic. The bit, for Shannon, is based on binary logic, and so the base unit could be a 1 or a 0, representing certainty or uncertainty. So, specifically, Shannon uses entropy borrowed from physics to formally represent uncertainty as a quantifiable measure. Shannon's information theory then allows for two important developments. Number one, it's founded on binary logic, and so its foundation is not singular but plural. And as a result, information theory does not insist on a fundamental unit that maximizes certainty, but rather a binary unit that creates possibility. So by introducing uncertainty into the heart of information theory, Shannon turns certainty or determinism on its head. Number two, by utilizing entropy as a quantifiable unit of uncertainty, Shannon opened the door to the use of information theory as a theoretical tool for examining communication in both nature and culture, thereby allowing for a common language and way between the human and the non-human. As to the latter development, Brimois quickly extended Shannon's mathematical theory of communication into physics by establishing the connection between information and thermodynamic entropy. He coined the term negentropy to represent information as a measure of order, famously using it to resolve the paradox of Maxwell's demon. Serres utilized Shannon's work and Brimois' enigmatic adaptation of communication theory to physics to develop his own broad-scale theory of communication that encompasses both the natural and social domains. In this way, Serres' network theory incorporates information theory as a theoretical tool that updates Leibniz's communication of substances. Serres' theoretical construct is reduced to a simple game theory-style communication model. In this model, a sender and receiver are engaged in conversation, and in order to communicate with each other, they must battle together against a third man who's a personification of the background noise that interferes with their communication. In Serres' model, the sender and receiver successfully thwart the third man by way of ideality. So what is ideality? Well, in the material world, or the world of accident, chaos, noise, and randomness, noise operates to suppress information and block communication. Inversely, ideality denotes the perfect communication, devoid of noise. For example, when people think about objects, they don't think in terms of actual physical objects, they think in terms of the ideas of the object. And so when I think of a chair, I don't think about an actual physical chair, but about the idea of a chair. Those ideas as non-physical ideals are purged of the material of accident and noise and chaos. We think in terms of non-physical ideas, not physical matter. Ideality then operates precisely like mathematical abstraction, which allows for us to conceive of pure forms devoid of materiality and the accidental. Mathematics as a formal language is an ideal communication that is maximally purged of noise. Ideality, then, formalized as abstraction, shows how the two players succeed in the battle against the third man, or noise, in the game of communication. This is fairly important to understanding Serres' use of mathematical structuralism. Serres tends to connect events via mathematical idealities. This is another example. Abstraction is fundamental to mathematics because it's the gesture of symbolizing patterns. We are able to conceive of ideal objects of thought and formal structures because of abstraction. So it's hugely important that abstraction is the mathematical conduit that enables communication. Now that's not to say that humans were not able to abstract until mathematics was developed, but rather primitive notions like abstraction, which are used in language, writing, and math, or other systems of meaning and knowledge, are fundamental to the operation of mathematics as a formal system of knowledge that's wholly independent of materiality as the idea. Notably, Serres' model of communication pertains to all objects in existence. All things emit, receive, store, and process information. So for Serres, everything thinks. Consciousness is a range of activity rather than just a limited scope of self-reflexive self-awareness. Everything communicates with everything else against a noisy, complex background. Also, in an effort to make the traditional, simplistic, Cartesian subject-object division more complex, Serres develops a conceptual schema for blending subject and object. He posits the quasi-object as the fundamental unit of knowledge in social organization. A quasi-object is an object kind of like a ball in a sporting event that circulates through the social body, and as it does so, it creates, maintains, and defines social bonds, passing between members of the collective. It defines and shapes the collective. Quasi-objects kind of operate like bonding agents or social glue, and given Serres' theory of communication, we can kind of see why. When members of the social body engage in commerce or communication, they pass around objects and ideas. And in doing so, members of the collective are compelled to arrive at agreeable terms on those objects and ideas, whether they are bargaining on transactions or sharing information that requires common terminology. This is the process of battling together against the third man to defeat noise and arrive at agreement. The social body self-organizes around the circulation of quasi-objects by engaging in commerce and communication under the god Hermes, the god of communication. In addition to Serres' development of the communication network, he also developed a form of structural analysis called logo analysis. To understand the logo analytic procedure, it's useful to understand the process of mathematical generalization. Often, a mathematical structure can be found to be a limited case of a more general structure. For instance, a line can be found to be a substructure of a larger network structure, or a grid can be found to be a limited and restricted case of a more general scaling network structure. The process of working from lower level structures and rules to higher level orders is called generalization. Higher order structures, being more general, are more flexible, refined, and adaptable. Generalization is akin to seeing the forest from the trees or gleaning the whole from the sum of its parts. Remember the story of people feeling different parts of an elephant and how they may or may not be aware of the fact that they're all touching the same animal? Well, this is like generalization, where mathematicians studying the properties of different structures could also be describing different parts of a larger overall structure. In Le Système de Leibniz, Serres demonstrates how generalization operates in Johannes Kepler's discovery that the celestial orbits are elliptical rather than circular as envisioned by classical astronomy. The entire classical schema was built upon the idea that circles and spheres represented perfection. Well, Kepler rejected the geometry of the sphere, and instead he considered the geometry of a cone, modeling the orbits of the planets according to the measurements of cones and conic sections. Whereas a perfect sphere in rotation produces a line as an axis, a sphere whose rotation has a wobble, called precession, produces a motion that traces a double-napped cone. Precession, or the planetary wobble, is what produces the four seasons and the complex weather variations. Double-napped cones can be divided by planar cross-sections that highlight a variety of different shapes, including circles, ellipses, hyperbolas, parabolas, and a fixed point. Although each of these shapes and their properties can be studied separately, they also can be shown to be part of a larger cone and subject to its properties. Generalization is the process of moving from the various parts to the larger whole to see the higher order operating over the various suborders. Mathematical generalization is the process of ascertaining a higher order structure from a set of lower level aggregate rules and structures. The simple notion of a perfect circle is expanded and complicated when the circle, which organizes around a simple fixed point, is just one shape among many others that are part of a larger double-napped cone. Serres shows how ellipses with two poles upset the simple notion of central order in a circle with a fixed point. However, ellipses are more general and prevalent than the more limited case of circles, which barely exist at all. When Serres performed a logo analysis of a structural event, plurality and generalization are the effect of comparing a simple order and a complex order. The complex order pluralizes or generalizes the simple event, retranslating it and giving it new meaning. The paradigm shift underway is important because it marks the end of the age of agriculture and the beginning of the age of communication. In this period, humanity transitions from economic life engaged in working the land and manufacturing products for consumption to increasingly living and working through our communications, interacting with smart homes and offices, and to the extent that we have to work, attending online meetings and get-togethers on computers, smart devices, tablets of all sizes. In order to analyze this situation, we have to use the most up-to-date theoretical tools, which today requires a shift away from centralized models towards decentralized models. Serres' philosophical network theory is a tool for thinking through this shift. He says, globally speaking, hominy seems to evolve from the sedentary model set up by the Neolithic agrarian revolution towards the nomadic model that appears to dominate today. In other words, we are shifting away from centralized models focused on agrarian settlements and large cities towards more nomadic and decentralized models where globalized travel and communications are involved. Notably, nomadic life in the age of communications and global travel is somewhat akin to the decentralized pre-agrarian lifestyle of nomadic hunting culture. Both the prehistoric and modern decentralized forms are opposed to and the opposite of centralized agrarian settlements in large cities that set up the era of foundations and foundational logic. It's as if human history oscillates between centralized and decentralized macro models, or the one and the many, the mono and the poly. Serres thematically calls the prior period the Promethean Age, the age of work, toil, and human production. This has been replaced and supplanted by the Communications Age, with Hermes, the god of communication, invention, and commerce, as the patron god. Modern artificial intelligence represents the grand finale to the age of agriculture and the full realization and commencement of the Communications Age, because AI and robotics replace the human producer at this stage. In short, the age of agriculture ends in full with the commencement of the technological singularity. The paradigm shift from agriculture to communications can also be formally represented as a move from hierarchical structures to network structures. In Serres' first book in the Hermes cycles, Hermes 1, Communication, he called it a shift from linearity to tabularity. The movement from line to table is also a dimensional shift. A one-dimensional line can be moved or translated to create a two-dimensional plane or surface, which is the basis for the table. In Serres' communication network, the network is composed of a plurality of points or vertices connected by ramifications or pathways that form a flexible, adaptable network structure. Each point is a thesis or definable element, and each path is a link or relation between two or more elements. By definition, no point is privileged and no point is subordinate, so the nodes in the network enjoy general equality. From the point of view of network theory, the questions of foundation then is superfluous, because subordination doesn't exist. General equality is the rule. Also, Serres situates mathematics as the most formal and fundamental language which seeks to designate truth. He recognizes mathematical temporality as driven teleologically towards higher orders of generalization on the one hand, and recursively back to precurrent origins that expose deeper and deeper levels of idealities. Mathematical idealities, which are the tools or elements or components upon which mathematics is built, they include formal elements like the line, sequence, or series, the number 0, abstraction, we've discussed generalization, but also whole numbers, integers, equality, the diagonal, the four basic operations of arithmetic, irrational numbers, and then also more recent and complex idealities such as integration, function, set theory, category theory, and also network theory. These mathematical elements combine to construct the mathematical architecture that informs our system of knowledge. Additionally, mathematical idealities are independent of the material world, but fundamental to the structure of the material world. So math, since its early days, has been recognized as a system of knowledge that's quasi-divine, because it composes the formal structure of a materiality, but is also independent of materiality, and has its own internal telos. In this way, math is both transcendent and immanent, much like the idea of incarnation. The God of communication speaks today by translating messages written in a linear format to messages written in a network format. To do this, the God must act as an interchanger, translating the message from one format to the next, and this is done because the message is preserved as an isomorphic relation that connects the two structures. Linear structures and schemes like dialectics and foundationalism can be shown through Serres' philosophical network schematization to be substructures of larger structural schemas. This non-foundationalist method causes linear models to unravel, as many of their important assumptions are reversed when one zooms out to a larger perspective. Dialectical argument is modeled in Platonic theory as a verbal engagement between two people representing opposing positions in a dialogue, through which transcendent immaterial forms or the telos can be grasped. This is eventually expanded by Hegel into dialectical theory, which posits a thesis, antithesis, and a synthesis that transcends the struggle and becomes the new thesis. Dialectical argument is argument by opposition, by negation, or agonistic adversarial struggle. Dialectics is transcendence through competitive rivalry. This method is popularized by Hegel, and then Marx famously turned Hegel on his head with dialectical materialism. For Marx, dialectics is historical such that the proletariat struggles against the capitalist bourgeois, and a new order is produced after a bloody revolution, eventually ending in a communist collectivist state. The dialectical social mechanism has not only dominated Western philosophy, but it's also been one of the most dominant theories of social organization in modern Western culture. On Serres' rendering, dialectical argument, which is a linear arrangement, can be graphed on a grid that maximally differentiates 2 points of opposition. Thesis and antithesis are constituted by 2 vertices maximally opposed. Compounding this structure creates a unilinear model where each step along the path is necessary and logical as a chain-like path of logical progression from point to point. This could be called the ordered sequence. On this formal model, the greater the imbalances produced by each link of the dialectical struggle, the more necessary and logical each progressive step in the pathway becomes. And as an effect of this increased polarization, a chain-like path of dialectics becomes more akin to a stick or a chain without links. This is what results when a relative order becomes absolute. As a result of this process, the dialectical model produces a continuous historicity that is irreversibly polarized towards an end and forever abandoning its origin. In other words, dialectics follows a linear sequence that is continuous or transitive, irreversibly polarized towards an end or anti-symmetric, and abandoning its origin or irreversible. Transitivity, anti-symmetry, and irreversibility are the 3 properties of a linear sequence or ordered sequence. Network structures, by contrast, propose an enormous number of possible paths from one vertex to the next, and no one pathway or line in particular is logically necessary. So there are many ways to the same destination, or many sequences of vertices to the same place, and no which way has priority. This is the difference between linear and tabular constructs. Linear games seem superfluous from the perspective of tabular networks. For example, dialectical struggle or rivalry, which is based on the line, is for Serres a game between 2 adversarial players who have simply lost sight of the fact that they're playing a game, and so they enter into a clash between the dominator and the dominated and play out roles. This enacts a master-slave dialectic spelled out by Hegel, and from the tabular perspective, however, these game players are equal within the network, where subordination does not exist. But within a linear context, the players just self-organize into roles of the dominator and dominated, and that characterizes the dialectical struggle. Logoanalysis often aims to unravel linear constructs by translating them into more general tabular formations. One of the most noteworthy examples of Serres' logoanalytic technique is demonstrated in his 1987 book Statues, where he compares the human sacrificial rites of Carthaginian Baal worshippers to the accidental deaths resulting from the 1984 Challenger explosion at Cape Canaveral. This comparison seems a little strange, if not off-putting at first, because people of modern cultures tend to view ancient sacrificial rites as primitive and unbecoming of more modern and sophisticated societies. But Serres argues that these 2 events are closely related in ways that should capture our attention. For Serres, humanity's anthropological origins are deeply rooted in collective sacrificial rites, which served as a self-organizing survival tool. To better understand the significance of collective sacrificial rites for Serres, it's useful to examine ways that the simplest form of order, or the line, produces a social mechanics based on the gesture of exclusion. Here we can use Serres' structural analysis in his essay Knowledge in the Classical Age, where he examines the ordered structure through La Fontaine's fable The Wolf and the Lamb. Dialectical struggle for Serres is a model that trends towards a rivalry to the death and mutually assured destruction. Serres' depiction of dialectical struggle is confluent with the academic work of his closest ally and friend, René Girard. Girard is the principal developer and proponent of the scapegoat mechanism, which Serres fully adopts and endorses as a theory of self-organization for early cultures. In part 2, we'll look at these topics in more detail, and we'll discuss the role of dialectical struggle, the scapegoat mechanism, and the sacrificial solution according to Serres.